Welcome to Study Guide Forum. Today we'll be looking at Gray-Lussac's law, and a mathematical expression of this law says that rate of diffusion is inversely proportional to the square root of relative molecular mass, and also rate of diffusion is inversely proportional to square root of relative density. So these are the expression of this Graham's law. Under constant temperature and pressure, the same temperature and pressure, rate of diffusion is expressed like this according to Graham's law. So we know that the rate is equal to 1 over time. So if rate is equal to 1 over time, then we can substitute for rate where we have, it will then mean that time is directly proportional to mass, relative molecular mass, and time is also directly proportional to vapor density, where we are comparing gases. If we are comparing two gases, then what we're going to do here is the gas 1 over gas 2 will then give us square root of relative molecular mass of gas 2 all over square root of relative molecular mass of gas 1. So for the density altogether, we have the same thing. So when we are dealing with time, if we are dealing with time, we have that is time T1 over T2 I'm sorry is equal to relative square root of the relative molecular mass of gas 1 all over square root of relative molecular mass of gas 2. So now what we are going to do here, but before we continue, we encourage you to subscribe if you have not, and then you can also share, like. But then this question we are going to be solving here will be in the description of this video, so that you always access it, so that as we are solving it, if you are not seeing anyone clear, you can look at the description and you see the question there, and then so that you will be able to enjoy what you are doing here. So in the question we have here, we have two questions that has to do with this. The first one has to do with finding the relative molecular mass, while the second one has to do with the time. The question said that a gas S diffuse twice faster as a gas Y under the same condition if the relative molecular mass of X is 30. Calculate the relative molecular mass of Y. So based on that, the relation that we're going to use is this. So that is what we're going to be using in order to solve this problem. So we're going to be using, now because we have gas S, we can say this one is for S, this one is for Y, equal to relative molecular mass of Y all over relative molecular mass of X all squared. So now for the relative molecular mass of the rate of X, the rate of diffusion of X is what? 2. The rate of diffusion of Y is 1, because the other one is 2 times. So the relative molecular mass of gas Y is what's unknown. This is what we're looking for. And the relative molecular mass of gas X is equal to what? 30. So now we are going to substitute all these things. For the other one, we have 2 over 1 equal to square root of relative molecular mass of Y all over square root of relative, that is 30 now. That is 30. So when we open up to solve this thing, we can square both sides. If we square both sides, this one will give us 2 times 2 will give us 4. This will open up the bracket. We have my over what? 30. So when we cross over, if we cross multiply, we have my is equal to 4 times 30. That will give us, that's the relative molecular mass. So the next one, we're going to be solving the second one. The second one says that given a given volume of methane diffuses in 40 seconds, how long will it take the same volume of sulphur 4 oxide to diffuse under the same condition? So we are going to be solving this one too. Here, since we are talking about time, we'll be using, this is for methane, CH is for methane, Y SO is for what? Sulphur 4. That's what we're going to use to represent them. So for the methane, the relative molecular mass of methane should be 16 because we have carbon and this. Carbon is 12 plus 4, we have 16. So we'll put 16 here. And then the other one, sulphur 4, is what we have 32 plus 4 times 16. That will give us 64. 4 times 16 will give us 60. Let me confirm it very well and be sure. 4 times 16 will give us, yeah, it's correct. That is, adding up this, we have 6. This other one will give us 96. So then what we have here will be square root of 96. So in this case, the other one, 40 seconds for the methane. Now we'll use our 40 seconds there. 40 seconds. So what we do now is to do the same thing. We're going to square. If we square that, square this end, and then we square. Why are we squaring? We are squaring to remove this square root. If we square both sides, by squaring here, this one will give us 1600, and then we have this other one will open. We have so what next? We cross multiply. If we cross multiply this by cross multiplication, we have give us 1600 multiply 96 equal to, this will be squared, 16 t squared. So making t squared the subject of the formula, we have all over 16. This will cancel, we have 100 multiply, we have 9600. So but then that is not what we are looking for. We're going to be, the actual value here will be the square root of that. So we have, so to square this, when we square it, let's take the square root. The square root of 9600 is, we have 997.9, approximately we say 8. So taking it to the nearest whole number, we'll have 98 seconds. So that is the rate of diffusion of the second gas, that is sulphur 6 or sulphur 6 oxide. Thank you so much for being part of the class. If you have any question, you can leave your question as a comment there, and we would like you to share, and then your subscription is a way of supporting us to do more. Thank you so much.